Welcome to my lecture. Myself, Dr. Arulprakasam, Department of Mathematics, SRMs of Science and Technology. Today lecture I am going to discuss application of Laplace transform, application of Laplace transform, Laplace transform to the second order to the solution of second order linear differential equation. So before that, starting this, already previous class I explained how to find Laplace transform. We know the formula. So now what is the main application? The Laplace transform application is how to find the solution of second order linear differential equation. Before that, what do you mean is general form of the second order linear differential equation? You know very well the standard form of second order linear differential equation. Suppose I am writing a naught d square y divided by dx square plus a1 dy divided by dx plus a2y is equal to some q of x. It is general form of second order linear differential equation. You know why it is second order? Because of highest derivative is 2 and then highest derivative power is 1 degree 1. So it is linear second order differential equation. So you know how to solve this problem. My general solution maybe it will come complementary function plus particular integral solution. You have studied the first semester how to solve this one. So now the same problem how to solve by using Laplace transform technique. Okay. Then generally in the Laplace transform here I'm using instead of the variable x variable to time variable you are using you know very well. So my second order linear differential equation general form is d a naught, it's an arbitrary constant, d square y divided by dt square plus a1 dy divided by dt plus a2y is equal to some function of t. So this is general form of second order linear differential equation. My thought is how to find this equation solution by using Laplace transform technique. So that's why we need some standard formula. So what is the formula? Formula. What is the derivative formula we studied the previous lecture. So now what is Laplace transform of derivative dy divided by dt? Everyone you know what is the formula is nothing but simply is denoted by L of y dash. It is first derivative with respect to t. That's just a notation. Then what is the formula for this first derivative formula? You know s into L of y minus y of 0. It is first formula, first derivative Laplace transform. What is the second formula? What is Laplace transform of second derivative with respect to t? Okay, is nothing but so L of y double dash of t. So what is the formula? You know already the general formula you studied based on the form s square L of y minus s into y of 0 then minus y dash of 0. It is formula. So how to solve this problem? Very simple. So just equation is given, just take Laplace transform. Suppose I am having the equation, it is rule or working rule. Working rule, you should follow this working rule. What is the rule? Suppose I have the equation d square y divided by dt square plus a1 dy divided by dt plus a2y is equal to some q of t, any function of t. Okay, first we can take, let my L of y right? L of I is equal to sum f of s. Just take it like this. So first step, take Laplace. First step is take Laplace transform on both sides. So what happened? If I am taking Laplace transform both sides, so by the linearity, so just I am taking L of just the equation I am substituting here is equal to L of Q of t. So you know Laplace transform of the equation by the linearity property, what I am getting? So A naught L of d square y divided by dt square plus A1 by the linearity property. L of dy divided by dt plus A2 L of y equal to sum L of q of t. Just we can apply the Laplace transform just to find out f of y, L of y. Okay, L of y to some function of s. Okay, what do you mean by function? Laplace transform of f of t. Just we can convert like this and then take inverse Laplace transform on both sides. What happened? So here inverse means I am getting y. Y is in terms of variable of t. I am getting L inverse of f of s is nothing but f of t. Yes or no? I am getting y is nothing but some original function of t. This is the general equation given how to solve this problem. One important thing we have to notice that some initial condition and given how to solve this problem. So we have to apply the initial condition. So I'll move on problem directly. First I'm taking this is the procedure. Again I'll explain once again. So second order linear differential equation is given. So how to solve this second order linear? The solution it's come, complementary function particular solution. How to solve some standard function. But we are going to how to solve this problem by using Laplace transform technique. What is the rule? Just you should know what is the Laplace transform derivative formula, and rule is take Laplace transform, find f L of y, and take inverse Laplace transform, you'll get original function f of t. So I'll move on problem how to solve this. Just I'm considering one simple problem. Suppose first problem. Solve problem 1. Solve the differential equation. Second, dy divided by dt square minus 2 times dy divided by dt minus 8y equal to 0. So here condition is given, initial condition y of 0 equal to 3 and y dash of 0 equal to 6. The question is strictly mentioned using Laplace transform. The question is given like this, how to solve this problem. Without this condition is given, we can solve any one method. But here strictly mentioned by using Laplace transform technique. So what is the rule I mentioned? First take what is the equation. Solution I can move. My equation is given equation is d square y divided by dt square minus 2 times dy divided by dt minus 8 times y equal to 0. It is given equation. Yes or no? So what is next? So I already mentioned take Laplace transform on both sides. Take Laplace transform on both sides. So what happened? Just I am taking Laplace transform L of d square y divided by dt square minus 2 times dy divided by dt minus 8 times y equal to L of 0. By the linearity property, Laplace transform linearity property, just I can apply L of d square y divided by dt square minus 2 times L of dy divided by dt minus 8 times L of y is equal to L of 0. Then what should I do? Just I can apply the Laplace transform of derivative formula. What is the derivative formula? So you know L of d square y divided by dt square. No formula. What is the formula? Nothing but s square L of y minus s times y of 0 s times y of 0 minus y dash of 0. We know that this formula. Yes or no? We know that this formula. First, second derivative Laplace transform. And similarly, you know what is first derivative dy divided by dt? Nothing but s times L of y minus y of 0. This is formula, already we know that. Follow this formula, I can apply the given problem, given equation. So my equation here, d square first second derivative 2 times first derivative. Yes. So here my question second derivative form is s square L of y minus s into y of 0 minus y dash of 0. This for first derivative, second derivative. For then see here second derivative of Laplace transform minus 2 times first derivative minus 2 times. So I can apply the formula s into L of y minus y of 0, then minus 8 times L of y. You know the Laplace transform of 0 always constant. Here 0 means I am getting 0. And one more thing here given, my initial condition is given. What is the initial condition given? In the problem, my initial condition is, here I mention y of 0 equal to 3 and y dash of 0 equal to 6. What is the meaning of this? The meaning is when x is equal to t equal to 0, my y value 3. That is the meaning. When t equal to 0, my y dash value first derivative at a point is 6 here given. So followed this, I have to substitute y of 0 value, nothing but here condition is in y of 0 equal to 3 given and y dash of 0 is 6. This is given. Alright. So simply I am substituting y of 0 equal to 3 and y dash of 0 is equal to 6. Here y of 0 value nothing but 3. Now I can simplify the equation likewise. So s square L of y. So here I am getting minus 3 times s. Here I am getting minus 6. So just I can multiply here inside minus 2 times L of y. Here minus minus plus. What I meant here 3 is there. 2 into 3 6 minus 8 times L of y equal to 0. Then what should I do? Here look at this equation. Here I have common d L of y here. Here I have L of y. Here I have L of y. Just I am taking L of y is common outside. So what about here? So what is the coefficient? S square minus 2 times and here minus 8. Yes or no? So here I have to missed one thing, L of y is. So here I missed yes, just yes. 2 times s into L of y. So minus 2 times s, right? Here minus 8. So I'm taking s square minus 2s minus 8 L of y. Yes. And then what is the remaining part? Minus 3s, here minus 3s and minus 6. Here minus 6 here plus 6 is there. Just cut it. Minus 3s equal to 0. Now I can simplify the equation likewise. So s square minus 2s minus 8 of L of y. So here minus 3s go to the right hand side. It will come 3s. So what is the main thing? I just find out what is our L of y. Follow this. Therefore my L of y is nothing but, so 3 times s divided by, come to this right, left hand side to right hand side, it will come here multiple form, it will come denominator form. So s square minus 2s minus 8. This is for L of s. It is first step. My first given, what is the rule? Given equation, just simply applied the Laplace transform and used the linearity property and applied the derivative Laplace transform derivative formula. I simplified, that means I got it what is L of y in terms of the function of, it is simply denoted by f of s, right? So what is the next? My motive is I am getting the solution. The solution is nothing but y of t, y value, it will comes function of t form. So next step is take inverse Laplace transform on both side. Take inverse Laplace transform, inverse Laplace transform on both sides, on both sides. So what I mean here, just I am taking inverse Laplace transform is nothing but L will cancel, so I am getting y of t because y is function of it. So L inverse of 3s divided by s square minus 2s minus 8. So everyone should know how to solve inverse Laplace transform. So here what are the method we discussed? We have partial fraction method, convolution theorem method, residue method. So any method we can follow. So generally we are following partial fraction method. So what is my f of s? My f of s here, let my f of s is nothing but 3s divided by s square minus 2s minus 8. So we don't have any direct formula. So we factorize the function. What is the factorization form? Take the factor form. So so 3s divided by, so what is the factor form I am getting? So I can make it s minus 4 into s plus 2. You know how I am getting the factor form? So s into s square. So adding these two, minus 4 plus 2 minus 2. So multiplying these two, I am getting this. This is given function. So here I can factorize the function. What is the factor? Look at the numerator side. Degree 1, denominator side is degree 2. So the p of x strictly less than q of x form. So what is the general factors? There is, it's a simple factor. So I can write the factor structure is a divided by s minus 4 plus b divided by s plus 2. You know it very well. Now take LCM on both sides. What happened here? A times s plus 2 plus b times s minus 4. So here numerator and here denominator is equal. So I am taking this 3s. Our main motive are to find out a and b value. You know how I am getting a and b value? Followed this equation. How I am getting this equation? Very simple manner. Just take LCM. I am getting this numerator side. I am getting the denominator side like this. So equating the left hand side and right hand side both equations. So I am equating the numerator side on both sides. So I am getting the left hand side numerator 3s and the right hand side numerator is nothing but a times s plus 2 plus b times s minus 4. How I am getting a and b value? By using the substitution method. What is the substitution method? If you want to a value, I can make put s value, suitable s value, I have to make it b value 0. So how I can choose the suitable s value? If I'm choosing s is equal plus 4, the value it will come 4 minus 4, it will come 0. So likewise I can find out a value. So now I can put, suppose I'm taking equation here, the equation put s is equal to 4. What happened here? S is equal to 4 is nothing but 12. So 4 into 3 are 12. So this value will be 0. So 4 plus 2, 6. So answer is nothing but 6A. So my answer A is nothing but, therefore my answer A value 2. How? So here 12. So it will simplify this, I am getting 2. And likewise, how I am getting B value? So just choose suitable S value to comes A. This term will be 0. So my better choice, put S is equal to minus 2. So what happened here? S is equal to, this term will be 0. So it is, I am getting minus 6. How I am getting? So here minus 2 into 3 minus 6. Here this term will be 0. This is nothing but minus 2 minus 4. Here look at, I am substituting, yes, 2 minus 2. So here minus 4 minus 6. Yeah, b into minus 6. So my answer b is equal to 1. So I got it, a value 2 and b value 2. So therefore my simple factor form, my f of s is nothing but a divided by. So what is our a value? My a value 2 times divided by s minus 4, plus what is our b value? My b value 1 divided by s plus 2. See, in yes or no? A divided by s minus 4 plus b divided by s plus 2. I am getting a value 2 and b value 1. So I simply substituted here f of s. Okay. This is my f of s. So my y of t is nothing but what? L inverse of f of s. So what is L inverse of my f of s? Nothing but 2 times s minus 4 plus 1 times s plus 2. By inverse Laplace transform linearity property, I am separating here 2 times L inverse of 1 divided by s minus 4 here plus L inverse of 1 divided by s plus 2. What is the suitable formula? You know the formula, L of 1 divided by s plus a. I can write e to the power minus at. It is well-known formula. We know the Laplace transform formula. That means inverse Laplace transform formula. Yes, here minus means it will come here plus or minus. Here it will come plus or minus. Yes, here plus means it will come minus. Here minus means it will come plus. Followed the inverse Laplace transform formula. I am getting 2 times e to the power 4t plus e to the power minus 2t. So it is y of t. This is my solution of given second order linear differential equation by using Laplace transform technique. So now I'll move on one more problem. This problem to solve the second order linear differential equation d square plus 4d plus 4 of y is equal to e to the power minus t. The previous function, right hand side there is no function. I consider 0. In the second problem, I can consider one exponential function. Also given that the initial condition y of 0 equal to 0 and y dash of 0 value also 0. Question is using Laplace transform method or technique. So method. So how to solve generally problem? First take what is the equation. I'm moving on solution. So what is the given equation? My given equation is d square plus 4d plus 4 times of y. It is nothing but You just modified the general form. You know it is operator. What is the, we know that operator, differential operator d generally is denoted by d divided by dt. Just I'm taking let here variable derivative variable, I mean y is function of t form. So the independent variable here t, right? So but for so I can rewrite this equation in this manner: d square y divided by dt square, right? dt square plus 4 times dy divided by dt plus 4y, just I applied here e to the power minus t. Just I am taking the equation first. So what is the rule I mentioned? First take Laplace transform on both sides. So what happened here? Just L of d square y divided by dt square plus 4 times dy divided by dt plus 4 times y is equal to, so e to the power minus t, L of e to the power minus t. Next, by the linearity property, I'm separating this equation like this. So sometimes this equation also denoted by, I have to mention one second. So y double dash plus 4 times y dash plus 4y is equal to e to the power minus t. So I can rewrite this equation in this manner also. Yes. So just I can apply the Laplace applying the linearity property. I'm getting L of d square y divided by dt square plus 4 times L of dy divided by dt plus 4 times L of y is equal to L of e to the power minus t. This is given equation for our concept. So like just I applied the Laplace transform linearity property here. So I am getting this equation continuous. Right. So you know what is the Laplace transform second derivative? What is the second derivative formula? So my second derivative formula, just I am using this formula. So s square L of y minus s times y of 0 minus y dash of 0. You know very well how to get second derivative, Laplace transform of second derivative. So the first step is over, plus, so 4 times, just I can apply the Laplace transform of the first derivative. It is Laplace transform of the second derivative formula. Just I can apply the Laplace transform of the first derivative formula. What is the first derivative formula? S times L of y minus y of 0 plus 4 times L of y is equal to Laplace transform of, what is the e to the power at formula? Laplace transform e to the power minus at, nothing but divided by 1 divided by s plus 1. Because what is the formula? L of e to the power at, L of e to the power at, nothing but 1 divided by s minus a, minus at nothing but s plus a. That is, got it, right? So now here initial condition also given. What is the initial condition here given? My initial condition here mentioned y of 0 value 0 and y dash of 0 value 0. What is the meaning? Whenever we have y of 0, I can substitute 0, y dash of I am substitute 0. So here the value is 0. Now I can simplify the equation likewise. So s square L of y, this term will be 0, right? Plus 4 times s times into L of y. So what about this term will be 0 plus 4 times L of y, it is divided by, is equal to 1 divided by s plus 1. Now here I have L of y, here I have L of y, here I have L of y. Take L of y commonly outside. So what happened? S square plus 4 times s plus 4 is equal to 1 divided by s plus 1. My things, first I have to find out what is our L of y. So it is multiple form. So it will come the numerator side. So it's a division form. S plus 1 into s square plus 4s plus 4. Yes. So how to solve this one? Just if one, just to factorize this one, what is the form? A square plus 2ab plus b square. So I can rewrite this form s plus 1 into s plus 2 whole square. But so how to solve this problem? So in the previous problem, I used a partial fraction method. Here I can use for convolution theorem method. Yes. So what is the convolution theorem method? You know the formula. By using here I am using by using convolution theorem method. The last class I explained what do you mean by convolution form, convolution theorem, what is the convolution theorem, convolution of two function, what is the convolution theorem also, right? By the convolution theorem method, I'm solving this problem. So what happened here? This is our L of y. So what is the next? Take inverse Laplace transform. Take L inverse on both sides. So what happened here? My L inverse of on both sides I am getting, so y of t equal to L inverse of f of s. Yes or no? Here my f of s is nothing but, here my f of s is nothing but 1 divided by s plus 1 into s plus 2 whole square. Here we can solve any one method by convolution, using convolution theorem method. I am doing this problem. Otherwise we can go for partial fraction method. Partial fraction method also we can try. So what is the partial fraction? A divided by s plus 1 plus b divided by s plus 2 plus c divided by s plus 2 whole square, like this. Otherwise convolution theorem method, you know how we have to split two function. What is the two function? So here I can take L inverse of 1 divided by s plus 1 into 1 divided by s plus 2 whole square. So what is the convolution theorem formula? Just I am taking L inverse of f of s into g of s. I can write out the form is nothing but f of t convolution of g of t. It is formula, convolution theorem form, right? So just I have to, in our f of s I am splitting what is our f of s form, what is our g of s form. L inverse of f of s and g of s, I can write out L inverse of f of s. So L inverse of 1 divided by s plus 1, right? Convolution of L inverse of 1 divided by s plus 2 whole square, right? By the convolution theorem I am writing this like this. So L inverse of two function f of s and g of s, L inverse of f of s and g of s value nothing but L inverse of f of s convolution of L inverse of g of s. This is the form. L inverse of f of s is nothing but f of t, L inverse of g of s is nothing but g of t. You know convolution theorem form. Okay, so what is the L inverse of 1 divided by s plus a is nothing but e to the power minus t convolution of, right, is nothing but by the shifting property. What is happen? Just take outside shifting property. Take outside 2, here 2 is given. So I take outside 2, what happened here? So I am getting e to the power minus 2t, right? So that I am getting L inverse of 1 divided by s square. So it is nothing but L inverse of e to the power minus t convolution of, thus it is convolution of the two function, right? E to the power minus 2t. So what is the meaning of L inverse of 1 by s square? Value nothing but t, you know very well. So this is for convolution of two function. It is my f of t and g of t, right? By you know the convolution theorem of two function L of f of t and g of t is, I mean f of t convolution of g of t formula nothing but integral f of u into g of t minus u into du. You know this formula. Followed the form, you know the formula, convolution of two function form, convolution of two function. Followed the function, I can write like this. So my function is, so so first here y of t is nothing but e to the power minus t convolution of e to the power minus 2t into t. Yes. So now I can apply the convolution of two function. So it's nothing but integral 0 to t, right? Integral 0 to t. So integral 0 to t. So my, whenever we have u, I can replace, sorry, t, I can replace to u. So I am considering this is our my f of u function. So I am getting e to the power minus 2u, right? Into it is u. Yes, into. So whenever we have t, I can replace to first in our function f of t, I can replace to f of u. The g of function I can replace to g of t minus u. This is the rule defined for convolution of two function. Here I consider this is my f of t function, this is my g of t function. In our f of t function, I replaced whenever we have t replaced to u. So I am getting here t, so I am getting u, t I replaced u int, right? This is it. So g of u, like g of t I can replace t to u, g of it is e to the power minus u into, I can replace t minus u, right? So I'm replacing t to t minus u here minus, so t minus u into du. So what happened here? I changed everything in terms of t variable to u variable. Yes. So now I can simplify this integration. What are the integrating variable is u. My integrating variable is u. So here integral 0 to t. So here e to the power minus 2u into u. Yes. So what about here? I'm in this step. I'm changing e to the power minus t plus minus minus plus e to the power u into t. So it is constant. So that, one second. So here by the exponential property, I am writing like this. So here integrating variable is u. So it is, there is no u variable, so it is constant. Just I'm taking outside e to the power minus t. So e to the power minus t integral 0 to t. So u times, just adding this, what happened here? I'm getting e to the power minus u. Yes, into d. Written this right. Now integrate by the Bernoulli formula, e to the u into e to the power minus u, so into du, into du. How I can integrate this one? By the Bernoulli formula or by Potts method. What happened here? E to the power minus t. So I can choose my u function. So here my u function is, so what is the formula? U dv, Bernoulli formula, uv minus u1 v dash plus u2 v double dash. This is the formula, right? Here how I can choose such a u function? My u function is successive derivative converts to 0. Suppose I'm choosing this is my u function. So what about if this is u? It is our u, this is our dv form, right? My u function nothing but here u, right, into, so e to the power minus u into dv integration value nothing but dv integration value v. So I am getting e to the power minus u divided by minus 1, followed by the Bernoulli formula. Here minus u differentiation value 1. So u1 u differentiation value 1. This integration value nothing but e to the power minus u divided by, already I have minus 1 is there, so plus 1. Okay, so now I'm substituting 0 to t. So now I can simplify this function e to the power minus t. So nothing but, so whenever we have u, I can replace u to t. I'm getting answer t times minus e to the power minus t. Here minus, right? E to the power minus t. So it is upper limit minus lower limit. It will come 0. So e to the power 0 value 1 plus 1. Yes or no? So I can simplify the equation. I'm getting the answer nothing but e to the power minus t, right? Minus t minus of 1 plus t into e to the power minus 2t. Okay, this is my solution. Now simplifying this, I am getting this solution. Thank you, students.